Alright, Friday night coding time. So this stream is for entertainment purposes only. I'm wrapped in blanket to protect myself from chills and after second dose of my vaccine. Um, let's see what we've got today. This stream is for entertainment purposes only. And today we're going to try to solve another coding challenge under 40 minutes or so, hopefully. Yeah, let's just jump right in. So today, no way, oh man, it's like 3D. I think I saw something like this before, but it was 2D. Now it's on whole another level. My gosh. Given an MN integer matrix, which defines the height, representing the height of each unit cell in 2D elevation map, return the volume of water it can trap after raining. Well, oh man, can I? It's all right. So let's just wait 40 minutes until it expires. I remember that 2D problem you can solve like in linear time. You just go like one way first, and then the reverse way to subtract whatever water is supposed to spill. That's how you get the volume, but now it's 2D, so you need to, you know. This is insane. I mean, all right, let me first remind myself how I solved the first 2D problem, all right, and then try to extrapolate it. But chances are, again, I'm not in the best conditions to solve hard problems today. Oh man, it seems my pencil is not working too. No, it seems okay. All right. Right, so let's see what we've got. So let's imagine we have some, right, something like the amount of water trapped here, if it's, I don't know, 5, this is let's say 4, right, this is, let's say, what, 3, 2, let's say this is 2, this is 3, right, whatever. So the amount of water here, so the algorithm was, all right, so the algorithm 1, go right and increment volume. It's obviously 2D volume, right? So because we now will jump to 3D, so we go here, and we start with 4, right? If the current maximum, let's say car max equals to 4, right? So we go and say, okay, 4, we don't do anything, then the second one will be, so 0 plus 4 minus 2 plus 4 minus 3, and then we have this bigger guy, so we say 0, but now our max is what? Is 5, right? So then we go whatever, plus 5 minus 4 plus 5 minus 3 plus 5 and whatever here, minus 4 minus 3 or 2, or doesn't matter. So 4 3, then it's 2, and then plus 5 minus 4, right? So we sum up all of these and we got a step 3, 2 plus 1 plus 1 plus 2 plus 3 plus 1, right? So the total is what? 4, 5, 9, 10. But the thing is, so far we count this thing, right? So we count water here, and it's okay, right? We also count that the new max happens somewhere in the middle, right? So then go in the reverse way. So we also count this water, this, and this. But obviously, this amount of water should be subtracted because it will be spilled over the right side. So, fourth step, we go, again, we start from 4. But now we know that this is max. So we add what? 4 minus 5 plus 4 minus 5, 4 minus 5, like 4 times, right? Until we hit the 5. So basically we say times 4, right? So this will subtract 4 units of water. So 1, 2, 3, and 4. Correct. That's how we fill this 2D in just linear time. Now we have 3D. The problem with 3D is that well, theoretically we should go one way like this. All right, let's say if we switch back to the default scene here, let's say we apply our algorithm here. So we will count 2 units of water here, 1 unit of water here, and 1 unit of water here. But once we go this way, we will subtract 1 unit here, 1 unit here, 1 unit here, or 2 units here, right? Or maybe here it will be even 3 units and 2 units, right? No, it will be nothing because it doesn't add anything. But you get the idea. So if you go this way, right, we see some trapped water, let's say here. But if we go this way, we don't see any water. So my point is, we can go first line by line, adding water, right, and subtracting, so we know it's filled, and then we go for every, let's say we go every row, and then every column we go again, and now we subtract. So we need to track one max and one position of this max, right? Correct. The only thing, we need to track the latest max position, because if there are 2 max, then obviously we need the last one before we go reverse side. All right, so let's have this private function, private which will tell us, or vector or whatever, or we want pair. Let's do pair of int, which will be so we return one integer, right? All right, so let's see. 2D trap. So we have this, now we need just one vector. Which is hey 2D, all right? And we can say, I guess it's const, we don't really care. We need int volume, all right? That the one that we will increment or decrement, and that's it. That's all we need, right? So we first go through every row or column, it doesn't really matter because it's a symmetrical problem, and count the overall volume, right? And we go one way, we subtract, such that once we finished with this, we go, if we went every row, we go every column, and knowing the maximum for every row, right? All right, so we will figure out what to do with columns later. Let's first implement our 2D cycle. So we say for, so we have int max h, let's assume it's 0, and int max index, let's assume it's -1. So we go for die equals 0, I less that hey2D size, I plus plus. So every time we first say max age, okay, let's do first like this. If max age less or strictly less, so if it's equal, we update it as well, then height to the I. So if max age is less or equal than height to the I, then we update max age, right? Max h equal height to the I, and max I equals I, right? So then we say what? We say volume plus equal what? Max h minus this thing, right? All right, so that's it, we're done. Now we have another cycle, I would say, which is now j, or we can keep I. That, let's say, starts from size -1. All right, and greater or equal to max I and I minus minus. Now we have, do we need the index, I wonder? What should we have? Okay, let's have vector of int, right? So that, we know that, let's say it's 4 values there. Maybe we need this maximum h2, but the idea is now we track max h2 and max I2, and basically we do similar thing. If max h2 lesser or equal than height 2d, we say that height 2d is I, right? And now what we do, and now we subtract or we can say we add this thing, right? Max h2 minus max h. So because max h will be greater than max h2, all right, so okay, we have it. And now we return, I'm not sure if we really need it, but let's see. Max h, max I, max h2, max I2, all right? So now, obviously here, first we go for, so we create int volume, which is initially 0. We also have vector of vector. Let's call it max heights. Which is what? Which is, let's call heightMap size. All right. We don't need it. Who cares? Yeah, the map itself, the length is not worth it to pre-allocate it. So let's just go like this then. Const auto height2d in heightMap, right? then we say max heights, push back, 2D trap, or should we call it trap 2D, so it's trap 2D, so it's more obvious what do we mean here. Trap 2D, it's height 2D, right? It's volume. Now, once we have it, so this will create 0 volume, this will be, I don't know, something here, something here, something here, right? This is 0. So this will be like 3, maybe 1, maybe 2, so whatever. So we create this unit volume here. So the problem now that, like in this case, like we will create 1, 2, 4, right? And here's something. So now we need to go another column and subtract. So how do we do this? Theoretically, we need to know. You know what? We don't need to store max here. We need different stuff. We need water level or something like this, right? So let's create a vector of water level. This will help. Vector int water level. Because we know exactly what it is, right? And we know that this is, again, the size of this thing, right? Size, and let's assume initially size is 0 by default. And then we also say that water level here is what is I, right, is equal to what? Max H. Because this is our water level that where we are. All right. And here we need to update it to say that this is max H2. That's why I thought we will need 2 of them. And now we don't need indexes because it's stored already. So let's call it water levels then. Here, so it's clear. Oh, we still have water levels, right? Water levels. We have some like 20 minutes, less. Need to hurry. Water levels, push back. All right, so now we know the water levels on everything. So every time we go, all right, so from water level, so we basically take the current one and then check the max along the column now, all right? So, all right, so let's see, 4, we can say in J to specify that this is a column now. j less than, let's say, heightMap obviously 0 size, right? J plus plus. And now we should have this for, again, this int string, int I, which is heightMap size I plus plus. All right. So now what we do is from our volume, we now need to so basically we want to find the max here, right? And then subtract whatever difference between max and this from this side and from that side. And from that side we also want to have this H2, right? So I wonder if I can just run whatever algorithm we already have. So we know the water level, right? Now we need to make sure that it will be covered by side walls as well. Ooh. Damn, it's not that straightforward in my mind. So we go by every element. We have these water levels, right? So yes, this is exactly the water level that we're looking for. So for every water level we have, we just subtract from this side, right? Water level minus, isn't it just this? Let me check. So we know what's the water at the specific cell, right? And we know so I guess we need something like this again. So let's see if I can repeat this stuff. H max I, then this. Now the only difference is that this thing is what is, oh man, it's heightMap J, and now it's J, right? So we track J. So J, and we track J, so it's max J. All right, so we subtract whatever is maximum currently we have in this specific setting from the water level, right? Once we did it, should it be vice versa? That's the question. Because we add the difference, right? So if max H is lower than water levels, it will be negative. It cannot be greater, I guess, because it will be the max as we go. So, okay. So like in this case, the water level here would be 3, right? The max H is 2 currently, so we subtract 2 minus 3 is minus 1, plus minus 1, so we subtract 1. Right, and then we do basically this thing again. Right now, once we did it, so once we went one way, right? Then I guess we still need this thing. The only difference now, what the heck, is that we don't need water levels anymore. Is that it's j, and this is int I. This is this thing because it's for the j. Actually, it's not. Is it I? I see. So I guess it should be vice versa. So we should just put this thing here, and then so we can say this is actually I, but it doesn't really matter. So right, so then we do column based approach. So this is j. All right, so this is j, and j is equal to this size minus 1, and j is greater than max j, right? So this thing, then j minus minus. And then we say, again, this heightMap by j, this is a j, and this is j, and it's now j2. So now once we have this maximum, we say, I guess similar stuff, right? And let's actually add minimum between this and 0. So if it's positive, we don't want to add anything. And same thing here. Now I guess the difference is max h2 and water level side j. Right, and then we finally return the volume. Finally, so and actually here we don't need it. It was just for this sub function. All right. This is what it is. We still have like 6 minutes, so my suggestion, just go straight ahead and try to debug on the example 1. If it works, then maybe we will be able even to submit it and maybe even to pass the checks. But it's unlikely. It's a hard problem, so. You see, we don't even have the right parentheses. Correct. So yes, it should be here. All right, so that this thing is here. This thing should be here. It's on top of this cycle. And this is this. Right. Alright, looks good. Is better. So we're given this, right? Let's actually print out here, see out first water level. So this is what I, right? I, and this is J. Oh man. And obviously we also don't combine. All right. 0, 0. Water level is 1. Which is, I don't really understand where is 1, 4, maybe from that side. 1, 4, 3. Right, then 1. Then I guess 3 if the water is here, and then 2, right? Alright, so it's this remote one. So we say 0, 0, 0, 1, 4, I wonder. No, we have 2. All right, so we have 2. So it was 2, then 3, then 3, then 3, right, then 4, then 1. All right, looks good to me. So it's perfectly fine. So it's 2, then starts 3, 3. So it captures water here, then 3, then it's 4, then it's 1, right? So for the middle one, we have 3, 3, 3, 3, 3, and then the last one is 4. All right, so this is correct. And so in here I assume 2, 3, 3, 3, 3, 1. All right, so these levels as it's supposed to, it works. Now, let's see. Let's see what interesting. So should we count volume there, or maybe we should count it here? Because in this case, all we need to do is basically once we count it, we take with the maximum between H and the water level in the specific cell. No, no. Yeah, you know what? It's too complicated. So you got the algorithm. I don't want to go through all the indexes, but this eventually will work. To some extent, I don't want to spend a lot of time debugging it today. I don't have a power. My mental power is not that great. Right, let me bring the volume here first to just see out total volume 1. All right, and then we have this wall, and then actually we don't need second one because we know that the second one is 7, right? So I would imagine that here should be 1, so nothing, 1, nothing, then whatever we're supposed to return for here, and then there, nothing, and then it's 2, this is 3, right, so nothing here, and between 3 and 3 is 1, so it's 2, so it will be 4 plus 2, 6, plus 1, 7, aha. So the volume is correct. We just do not subtract anything. So the first volume is 7. All right, so let's just figure out how to subtract properly, and that's it. Total volume 7, that's what we return actually. That's why it's a little bit incorrect, because we should subtract this and nothing here. So, all right, so the water level is fine. So what we say here is max H and max G, all right? So we go now J thing. So we say, okay, we start from here, right? So it's 1, then 3, and then 2. So we say, okay, it's 1, water level 1, so we don't do anything. We don't need to subtract. Then we update max H, it's 3 now. We say 3, and then the corresponding level 1, 0 is 3, it's again 0, so we don't need to add anything to the volume or subtract from the volume. So we go to the last one, is 2. But max H is 2. So I almost cracked it. So because max H in this case is now 3, and we have 2, the minimum is 0, right? So it's positive, so we don't change the volume. And we shouldn't, right? Really. Because we don't care. Now, once we go the opposite way, so we start from this thing, from 2, until we hit the middle element, including the middle element. So now we say max H2, and first is 2, from water level is 2, it doesn't change anything. All right, so we got it, right? Now, the most interesting column for us is actually J. Oh, wait a second. So this is I, right? No, I is what is size of the map, which is 3. Right, so yeah. A little bit screwed here. I guess we need what? It should be vice versa. This should be J. And this should be I, right? So it should be, okay, let's assume, so the J is this, and I is this, right? So then we should change the indices here. Oh man, super confusing. So we fix I, right, and then we go this way, and we shouldn't. We should go row by row. All right. Man, it's a lot of mistakes, but that's okay. Everything JI, right? So let's run the code one more time. It works! Hey, it works! Not sure if it will work all the time, but let's see. Maybe we will be too lucky and it will pass all of the checks, but I doubt. Most likely not, and some complicated case, obviously we won't debug it. Alright, so somewhere off by 1. I think this mean part is really what messes up. So we subtract the difference, right? And if height is for some reason greater than water levels, we don't care, and vice versa, we should care, right? All right, but we're almost there. Almost there. I would believe it's just okay. 17 out of 42. For hard problem, it's okay. Should we try to debug it? It's more complicated. It's 1, 2, 3, 4, 5. Oh no. So let's see. So we expect 14 and output 15. So what we've got as the total volume, and then the map. 26. Alright, so it's 12, 13, 13, 12, and 13. Interesting. So in this case, actually, yeah, because it starts with 12 here, we won't have anything on the edges, so we don't care. So, but okay, let's say 13, 4, 8, 13, 13. So we have something here. Yeah, but it's super hard to debug now. Almost everywhere 12, 13, and we are off by 1, just by 1. So let me check. So we go this direction. Now, you know what? I'm done. I don't want to spend my life on this nonsense. The algorithm is clear. It's linear with respect to number of cells, and some indices here and there, and this thing should work. It works for like half of the tests already. Just don't want to spend my time on debugging this 2D stuff. Nonsense. So, okay, we've got what? We've got 17 out of 42. I'm done here for today. Right, so 0. This is 0, and you know what? I don't care. This is 17 out of 42. All right, done. See you at least sometime during the weekend.